Hello, I'm Nix, and today we're going to be solving the sort array by parity problem on the LeetCode website. As always, we're doing this in C++, and I'm going to give you a detailed explanation of the entire process, from the planning of the algorithm, to the coding of it, to the analysis of time and space complexity, as well as looking at the LeetCode rankings. If that sounds good to you, then stay tuned. Welcome back. Let's get right to it. Given an array A of non-negative integers, return an array consisting of all the even elements of A, followed by all the odd elements of A. And we can return any answer array that satisfies this condition. Then we're given an example here, which is exactly the opposite of what we want. All of the odds are in front, and all of the evens are in back, which is not what we want. So we want all the evens in front and all the odds in the back. And considering this statement, this array we would be happy with, this array would be happy with, and all of these others. We don't care what specific order the even numbers are in within themselves and all the odd numbers are in within themselves, as long as we get all the evens first and then all the odds, and that partition exists, we're happy. Now note, even though this problem doesn't specifically say so, because it's in the in-place operation section, that's where my mind went to for solving the problem. So we're going to solve this with an in-place method as a requirement, even though the problem doesn't specifically say so. Final look at constraints here. We could be potentially given an array with only one thing in it, and we're only dealing with positive numbers. Now, from that extra condition here that I imposed, how do we solve this problem via an in-place way? Well, let's take a look at this problem more closely to figure out what steps the algorithm would need to consist of in order to be able to achieve that. Going through the array, the first thing I see is an odd number. Now, that would not be an issue if the array consisted of entirely odd numbers, but because we do have even numbers here, we need to change things up here. Now, this first number should be one of the even numbers, and conversely, this number here should also contain an odd number, but it doesn't. It contains an even number, while the first position contains an odd number. That is not good, but if we switch those specific numbers around, 4 becomes the number in the first position, 3 becomes the number in the last position, then we have the situation where the first number is even, the last number in the array is odd, and that's good. So those positions are secured. We can shift now what we're looking at to one above that position from the start and one below that position from the end. So in the original array, again, we have a situation where we are seeing an odd number where we want to see an even number, and we're seeing an even number where we want to see an odd number. Again, we can do that switcheroo and place the even number where the odd was and the odd number where the even number was, and after doing that, we get this array here. Now, this methodology clued me into some of the core scenarios that I need to pay attention to. So come on in, handy dandy whiteboard. Now, this problem, we saw 2 scenarios play out, but covering all the things that we could potentially see, there are 4 total scenarios that we could see when looking at what's in the first position and what's in the last position of an array. We could see what we had here in the example, where the first position contains an odd number and the last position contains an even number. Well, that's exactly what we do not want, so we can do a switcheroo. We could place the even number where the odd number is and the odd number where the even number is. We can then see a situation where we have an even number in the first position and an odd number in the last position, well, in that case, we can shift our positions by 1. The starting point moves up, the ending point moves down by 1. The final two scenarios that we could potentially see are where the beginning position of the array and the odd position both contain odd numbers. Now for the ending position, that's exactly what we want, so we're good with that. But this first position being odd is only going to be good if the entire array doesn't contain an even number. So we're going to hold off shifting this starting position, and we're going to shift the end position and look through the array, and if we see an even number, well, then we are in scenario 1, where we see an odd number and an even number, and we want to switch them. The mirror image of that above scenario is where both the starting and the ending positions contain an even number. But in this case, it's the beginning position that we're fine and dandy with, and the end position we want to hold off on moving until we go through the array and make absolutely sure that we don't see an odd number present. So that beginning position will shift up by 1 every time, verifying that are we seeing even numbers all the way across the way? And if we don't, and we find an odd, well, we revert to scenario 1 and we switch them around. So with those 4 potential situations present, and having to look at and compare 2 positions within the array, the structure of the algorithm starts to form. What we need is a couple of integer variables that look at the starting position and the ending position of the array. We're going to need a loop. Now, in this situation, when we're deciding are we going to use a for loop or a while loop, this is going to be a good case for using a while loop. Because depending on what the specific properties of the array, I'm not entirely sure how many times this is going to have to execute. But I know the condition when to stop the loop. In other words, if we continue moving these starting and ending positions all the way to a point where essentially they cross over each other, and the starting position is now no longer smaller than the ending position, I will have guaranteed that I've looked through the entire array, and then I can break the loop. So I know that condition, but I don't know, depending on the array, how many times it's going to have to execute in order to meet that condition. That is an excellent situation to use a while loop and not a for loop. Because for loops, you need to know how many times it's going to execute. So we have those integer positions, we have a while loop with the condition known to how to end the loop, and we know 4 scenarios that we could possibly come across, and we know how to handle them from the above discussion. In one scenario, we want to switch around the values that we see. In another scenario, we would just want to increment both of those positions. And in the final 2 scenarios, we want to increment one of the position trackers, but not the other. So with all of that discussed, let's move on to the coding phase here. First up is creating all of the integer variables that I need. Created a starting position that I named starting index, and I set it to 0. And I created a second position, named it end index, and I set it to the end, a.size -1. Now I also created a third one that I named temp holder, because with switching around those values, I'm going to need this one if I'm doing the switch or the swap by scratch from raw code. Now C++ has a standard template library function called swap that can handle that for me, but I'm going to do this with just raw code, and I'm not going to use that built-in swap function. This is the start of the while loop and the first condition to look at. So while the starting index is less than the end index, we want to continue the loop. Once that condition is not true, we break out of it. The first scenario we want to look at is where the start is even and the end is odd. In that case, that's exactly what we want. So to code those conditions, We want the value of the array at the starting index position, and take that value and do modello 2 on it. So the modello function, we're interested in the remainder that you have after the division is completed. So if this value is an even number, when you divide it by 2, you're not going to have any remainder, so the remainder is going to equal 0. So if this is even, the modello 2 value is going to be 0 for it. We have the AND operator here. And then we do the opposite for the end index. So the value at the end index position, we divide that and we want to look at the remainder. If that remainder is not 0, then this value must be odd, because an odd number divided by 2 is going to have a remainder of 1. So this is essentially if the number is odd. This is saying if that number you're looking at is even. And in this situation, we want to increment the starting index up by 1, and we want to decrement the ending index down by 1. Next up is a scenario where both are even. So both of those modellos are going to be equal to 0. And in this case, this is the one where we are happy with what's at the starting point, but we aren't sure whether this even number at the end is a good thing or not, because it depends on what else is in the array. So to figure that out, we're going to increment the starting index along and see if we can find an odd number, because we know that this even number at the start is definitely a good thing and what we want. It'll increment until we find an odd number, and then it reverts to a scenario where we have an odd number and even number to switch around, which is going to be handled in a different branch. Next up is the opposite situation where both are odd. Again, with modellos, they both will not be equal to 0 now. And this is where we want to only increment the end index. We want to freeze the beginning index because that could potentially contain something that we need to switch with. The final scenario is what's going to actually handle the switch. So the start is odd, so its modello is not equal to 0, and the end is even, so its modello is equal to 0. And for this method of conducting a swap, I am going to need a temporary holder to, well, as its name suggests, temporarily hold one of the values as I overwrite the other one with the second one. Going through this, you set the temp holder to initially what the value of the array at the starting index is. So if we have this example here, and I've essentially whittled it down to odds versus evens, since I don't care what they specifically equal, I'm going to want to set temporary to whatever this odd number is. So temp now holds odd. Now what I'm going to do is that same value at the starting index position, I'm going to set equal to whatever the value is at the end position that I'm looking at. Say this even right over here. So this odd is now overwritten with that even number. Now I want to turn this position into the odd number here. But notice if I didn't have that temporary holder, I would have just overwritten and deleted the value and would have no way to retrieve it. So because this temporary holder still holds it, I can now just set the position at the end to the temporary holder value, and that will set this position to that odd value. The final thing to do is, because this function expects a return value that's a vector, we just want to return the value that it gave us in the first place, because we've done this in an in-place way and that array was modified itself. So return A. And with that last addition, this algorithm should be able to handle any situation. You see, if we are given the edge case of only being given an array with just one thing in it, well, the starting index and the ending index are equal in that case. So this condition here is now false, and we never go into the while loop to begin with. So let's go ahead and run code and see what we get. Pending, judging, more judging, still more judging, finished. Okay, All right, we have all of the evens in front, all of the odds in back, and this is one of the few times when my answer and the expected answer here could be different, and I don't need to freak out because this will still fulfill the condition. We should be good to go. Now let's prove that and go the full shebang. Pending, judging, accepted. Excellent! So this algorithm works. Now let's move on to the analysis of said algorithm before we click the button here for rankings. As I stated in the beginning, this is an in-place method for solving this problem. And as a result, because I only had to make some integer variables and didn't have to make an additional container, this has constant space usage. And with constant space usage, that means my space complexity is on the order of big O of 1. In terms of time complexity, I only have one while loop here, and the only thing that the while loop contains are some if statements and some constant time work statements here, so nothing that would have a variable time dependency. So the while loop essentially runs until it goes through the entire array. And since it is working through that array, it's going to depend on that array size. So this solution has a time complexity of big O of n, linear time, where n is the size of the input array. Okay. Now let's see where we are in the rankings. I've clicked. I want to be able to see. Thank you. Alright. Runtime is in this distribution here. This distribution seems to indicate to me that these are going to be the various big O of n solutions, and I would probably ping pong around these bars here. But these little small ones here are probably other ways of doing it, maybe creating additional containers, maybe using sort functions that, because sort is n log n, it would have worse time complexity. So those are probably alternative solutions down here, while big O of n solutions are up here. Okay, and solution is essentially middle of the pack in terms of space usage, with a pretty decent range here. Again, probably way in the back here are solutions that are going to use additional containers, and maybe things up here are ones that used one less variable, but essentially right around and would probably ping pong around this area. That was the sort array by parity problem. I hope you got something useful out of this video. And as always, I will wish you happy coding and to have a nice day.